March 1987. The skies over Jalalabad, Afghanistan. The cockpit of the Sukhoi Su-25 Frogfoot rattles with turbulence. Below, the tan and grey spine of the Hindu Kush Mountains cuts through the haze. To the pilot, a captain in the Soviet VVS, the landscape is a tactical map. A column of his army's motorized rifles is pinned down in a narrow valley, a squawking distress call painting the target in his mind. His head-up display glows green. His Shkval laser rangefinder and targeting system is slave to the coordinates. The standard procedure is now muscle memory. Acquire, lock, release. He rolls in for his attack run, his eyes scanning for the telltale flash of Mujahideen gunfire. But as his thumb moves to the weapon release button on the control stick, the green symbology on his display, the comforting geometry of a functioning radar, simply vanishes. Not a flicker, not a failure warning. It is a silent, digital void. His ground mapping radar, a key sensor for low-altitude attack in this terrain, shows only snow. His air-to-ground missile seekers find no purchase. In his headphones, there is only the hum of his own aircraft and a sudden, profound electronic silence where his situational awareness should be. He is flying blind into a wall of unseen, targeted noise. The valley below is no longer just a landscape of rock and insurgents. It has become an invisible cage of electromagnetic energy built in a laboratory half a world away. This baffling blindness was the first symptom of a new, invisible war. To understand the shock of that electronic silence in 1987, one must first hear the deafening roar of Soviet air power that defined the early years of the war. December 27, 1979. Operation Storm 333. The Soviet invasion was not a blunt force armoured push, but a precise air-centric decapitation strike. While Spetsnaz units stormed the Tajbeg Palace, the skies over Kabul belonged to the USSR. Columns of Antonov An-22 and Il-76 transport aircraft disgorged the 103rd Guards Airborne Division and the 345th Independent Parachute Regiment onto the tarmac of Kabul International Airport. This massive air bridge, a logistical feat, demonstrated from hour one that the Soviet Union considered the skies its uncontested domain. For the Democratic Republic of Afghanistan's DRA nascent air force and the scattered pre-modern Mujahideen, the concept of challenging this dominance was laughable. The initial Soviet military doctrine for Afghanistan, refined from their experiences in Hungary and Czechoslovakia, envisioned a quick, stabilizing intervention. Air power was the linchpin of this limited contingent strategy. Its role was threefold: mobility, fire support, and terror. The workhorse of mobility was the Mi-8 HIP helicopter. Flying in vast, thundering formations, these machines moved troops, supplied remote outposts, and conducted rapid anti-partisan sweeps. They were the taxis and trucks of the war, turning the impassable mountain ranges into traversable space. But when resistance solidified, the Mi-8s shed their transport role and became gunships. Outfitted with pods of 57mm rockets, heavy machine guns, and later, devastating 80mm S-8 rockets, they became flying artillery. The psychological impact was profound. For a guerrilla fighter with a bolt-action rifle, the sudden appearance of a dozen Mi-8s, filling the valley with the mechanical shriek of their turbines and a storm of high-explosive rockets, was an encounter with an alien, invincible power. For heavier strikes, the fixed-wing fleet entered the fray. The Ilyushin Il-28 Beagle, a veteran light bomber from the DRA's own inventory, was used for carpet bombing suspected base areas. But the true symbol of punitive air power became the Su-25 Frogfoot. Designed specifically for close air support, its cockpit was a titanium alloy bathtub, its engines rugged and separated to survive battle damage. It could loiter over the battlefield, its pilot identifying targets visually before delivering a horrific payload of bombs, cluster munitions, and its fierceable twin-barrel 30mm GH-32 cannon, which could reduce a mud brick compound to dust in seconds. The technological mismatch was absolute. 5mm anti-aircraft gun, which was cumbersome and rare. Most engagements were with small arms, the crackle of Kalashnikovs and PK machine guns firing hopelessly at armoured underbellies and retreating jet exhausts. Soviet pilots reported watching tracer fire arcing lazily, thousands of feet below their flight paths. Their radar warning receivers, designed to scream in the presence of NATO's surface-to-air missile locks, remained silent. In the cockpit, it was a clinical, almost boring form of warfare. Acquire the target, release ordnance, and turn for home. The threat was statistical, not existential. A lucky round might find a hydraulic line, but the sky itself was Soviet territory. This period bred a dangerous confidence, a systemic arrogance. Flight manuals for low-altitude attack profiles were followed to the letter. Attack runs became predictable. The Soviet Air Force, VVS, and Army aviation operated on a rhythm of overwhelming technological superiority, where sensors always worked, missiles always locked, and the enemy had no means to reach out and touch them in their metal cocoons. This unchallenged dominion would not last. The very predictability of Soviet air operations became their greatest vulnerability, a pattern studied intently from across the Pakistani border by handlers from the CIA and Pakistan's Inter-Services Intelligence, ISI. The first crack in the facade would not come from electronic noise, but from a single infrared-seeking streak of fire. The catalyst for change arrived in the spring of 1986. It was a physical object, but its impact was profoundly psychological. Its name was the FIM-92 Stinger. The Stinger was not the first man-portable air defense system. Man-pads the Mujahideen possessed. The British blowpipe and the earlier, less reliable American Red-Eye had been supplied in limited numbers. But the Stinger was a generational leap. Its IBCM, Integrated Battery Coolant Unit, pyrotechnic cooler, gave its seeker head a crucial 45 seconds of readiness. Its IFF, Identification Friend or Foe system, though often discarded by Mujahideen operators, spoke to its sophistication. Most importantly, its seeker was superior. It could engage a target head-on, chasing the intense heat of a jet engine, not just the weaker infrared signature of exhaust. For the Soviet helicopter pilot, whose survival tactic was a sharp turn to present the tail to a heat seeker, this nullified a fundamental escape maneuver. The first confirmed Stinger kill is believed to have occurred on September 25, 1986, when a group under Commander Ghaffar in Jalalabad downed 3 Mi-24D helicopter gunships in quick succession. The effect was electric and immediate. Rumours of the new weapon, its compact size, and its terrifying effectiveness spread through the Soviet ranks faster than any official bulletin. Pilots who had once flown with detached confidence now scanned the ground not just for targets, but for the distinctive, pale smoke puff of a Stinger launch. The angry bee buzz of the missile's motor became a sound that triggered pure adrenaline. The Soviet high command was forced into a rapid, costly tactical shift. Helicopter operations were revolutionized overnight. The low-altitude nap of the earth flying, once a tactic for surprise, now became a desperate necessity for survival. Attack runs were flown at higher altitudes, degrading accuracy. Expensive flare dispensers were hastily installed on every aircraft, creating a constant demand for pyrotechnic cartridges. The most significant change was a move towards standoff attacks, 5-mile engagement envelope of the Stinger. This preserved aircraft, but it also dramatically reduced the effectiveness of air support. A bomb dropped from 10,000 feet onto a mountain valley was a gesture, not a precision tool. Soviet ground forces, feeling the sudden reduction in timely, accurate, close air support, began to complain bitterly. It was within this new, tense operational reality that the fixed-wing fleet, particularly the Su-25, gained renewed importance. The Frogfoot, with its higher speed and higher operational ceiling than helicopters, could theoretically deliver ordnance more accurately from a safer altitude. Its armour offered better protection against the shrapnel of a near miss than a helicopter's thin skin. The Su-25 and other jets like the MiG-23 MLD fighter bombers were pushed to the forefront of the fire support mission. Their primary tool for this was not dumb bombs, but precision-guided munitions, or rather, the Soviet analogue. The Su-25 was equipped with the Klon laser rangefinder target designator linked to the Shkval system. It could guide laser homing missiles like the Kh-25ML. More commonly, pilots used the system to compute release points for unguided bombs and rockets, increasing accuracy. Crucially, for navigation and for delivering these munitions in Afghanistan's featureless, repetitive terrain, pilots relied on their onboard radars. The Su-25's Shtik radar altimeter and ground mapping radar, and the more advanced Sapphire radar in the MiG-23 were their eyes in the high mountains. These systems painted an electronic picture of the world below, allowing them to find target coordinates, navigate to them, and calculate weapon release points even when visual identification was difficult. The stage was now set. The Stinger had forced Soviet pilots higher, making them more reliant on their electronic sensors than ever before. They had adapted to the visible threat, the heat-seeking missile. But as they adjusted their tactics to counter one American technology, they flew directly into the kill zone of another, far more subtle one. The CIA and ISI were not merely supplying defensive weapons. They were architecting a complete system of denial, layering threats. The Stinger was the fist that forced the head up. The next weapon would blind the eyes. This electronic ambush was the logical next step in a covert technological war, and its instrument was already in theater, humming quietly, waiting for the perfect frequency. For the Soviet pilot, the cockpit was a sanctuary of ordered information. Gauges, dials, and increasingly green-tinted cathode ray tube displays presented a digested, manageable version of the chaotic world outside. Mastery of this machine-mediated reality was the essence of his professionalism. The war, though brutal on the ground, had maintained a certain electronic purity in the air. His radar warning receiver, RWR, the SPO-15 Berioza, was a silent sentinel. Its lights and tones were keyed to known NATO frequencies, the specific pulses of a Hawk missile battery, the search pattern of a Roland system. In Afghanistan, it was mostly quiet. The threat was ballistic, not electronic. A gunner aiming a DSHK was not painting him with radar. A Stinger launch was a passive infrared event, invisible to his RWR. This created a profound sensory expectation. The first symptom of the new threat was not an alarm, but an absence. During a critical attack run, the ground mapping radar return, a fuzzy green-grey representation of the terrain crucial for final navigation and weapon release, would dissolve into a swirling, meaningless soup of grass or simply go dark. The pilot would instinctively check connections, cycle power, perform the basic drills for a malfunction. But the systems were not dead. Other avionics functioned. The malfunction light did not illuminate. The psychological impact was deeper than mere instrument failure. It was a violation of the cockpit's sanctity. If the radar was blind, what else was compromised? Was his communications channel, his lifeline to command and warning of other aircraft being monitored or jammed? Had the enemy somehow spoofed his navigation systems, leading him away from his target, or, worse, into a box canyon? The disorientation was cognitive. A pilot trained to process streams of electronic data suddenly had to fly, navigate, and fight on pure visual reckoning in some of the world's most disorienting terrain. The mountains of the Hindu Kush offered few distinct visual landmarks. One brown, jagged ridge looked much like another. The stress of the Stinger threat was now compounded by a terrifying, silent void, where his technological confidence used to be. Debriefings from this period, later studied by Western intelligence, reveal a pattern of confused, frustrated reports. The initial hypothesis was not enemy action, but either a surprising atmospheric phenomenon or a critical flaw in their own newly fielded equipment. This confusion was the ultimate goal of the electronic attack: to sow doubt, degrade effectiveness, and, most critically, to mask the true source of the problem until it was too late. The pilot, trained to fight a visible enemy, was now wrestling with a phantom. To comprehend the scale of this Soviet bafflement, one must understand the two technologies at silent war: the hunter's eye and the jammer's blanket. The Soviet systems were robust, utilitarian, and designed for a European war. The Su-25's navigation and attack suite centered on the Shtik radar system. This was not a powerful long-range fighter radar, but a simpler set, a radar altimeter for precise low-altitude flight and a ground mapping mode. It emitted pulses of radio energy in the I-band, around 9 to 10 GHz for mapping. The return signals painted a basic picture of the terrain below, allowing the pilot to correlate his position with a map. The more advanced MiG-23 MLD fighter bombers carried the Sapphire 23ML radar, NATO, High Lark. This was a genuine air-to-air and air-to-ground radar operating in the J-band, around 15 to 17 GHz. In Afghanistan, its ground mapping and ground-moving target indicator modes were invaluable for finding convoys or camps in broken terrain. Both systems were pulse Doppler radars, a technology that filters out ground clutter to track moving targets. They were the electronic workhorses of the tactical strike mission. Against them, the CIA deployed a weapon of precision electronic denial, the AN/ALQ-167V jamming pod. This was not a broad-area jamming system like those on dedicated EW aircraft. It was a tactical stand-in jammer. The genius of its deployment lay in its adaptation. S-pilots. It was compact, modular, and crucially programmable. CIA technicians working with ISI counterparts reconfigured these pods. They analyzed the specific frequencies of Soviet aircraft radars, intelligence gleaned from listening posts in Iran, from defectors, and from battlefield captures of downed aircraft. The modified pods were not merely noisemakers, they were surgically intelligent. They listened for the specific pulse repetition frequency, PRF, of a sapphire or shtick radar. Upon detecting it, the pod would transmit a delayed, amplified echo of that same pulse back at the aircraft. To the radar's processor, this looked like a massive, confusing return, a ghost mountain range appearing across the entire scope. This technique, known as terrain bounce or corruption of the range gate, effectively blinded the system without alerting the pilot with obvious interference. The display didn't go black. It became a meaningless, luminous fog. It was a mirror held up to the aircraft reflecting its own signal as nonsense. The pod was powered by a simple battery pack and could be operated by a trained Mujahideen team. It was often placed on a high mountain ridge overlooking a known Soviet flight path or a valued Mujahideen base area. When spotters saw aircraft approaching, the operator would switch it on. The effect was a localized, invisible dome of electronic distortion. A Soviet flight of 4 aircraft would approach the valley. The lead plane's radar would dissolve into noise. He would report a malfunction and abort the run. The next pilot, seeing his leader turn away, would assume a technical problem or a Stinger threat warning, and also turn. A single 60-pound pod operated by one man on a mountainside could halt an entire airstrike without a single shot being fired. This was the core of the bafflement. The Soviets were not prepared for a peer-level electronic warfare threat in Afghanistan. Their doctrine assumed EW would only be encountered in a full-scale war against NATO. They had no effective countermeasures for their tactical aircraft in this theatre. The enemy had not just acquired a new weapon, he had mastered a new dimension of warfare. The introduction of the ALQ-167 pod did not operate in a vacuum. It was the keystone in a deliberately constructed, multi-layered kill zone, a grim evolution of Mujahideen tactics under CIA and ISI tutelage. This was no longer guerrilla warfare as sporadic ambush. It was a system of integrated air defense, orchestrated from afar. The process began with meticulous intelligence. Mujahideen scouts and often ISI observers using long-range optics and communications intercepts would identify predictable Soviet flight patterns, the routes to known garrison resupply points, the approaches to valleys housing major bases. These corridors became hunting grounds. The tactical deployment was a masterclass in asymmetric warfare. A typical nest would be established on the dominating high ground of a valley. The position was not chosen for its cover from gunfire, but for its line-of-sight electromagnetic coverage. The team consisted of several key players, spotters with binoculars and radios to give early warning of aircraft approach. The EW operator, trained to recognize aircraft types by silhouette and to activate the jamming pod as the lead aircraft entered its effective radius, typically 15 to 25 kilometers depending on terrain. And crucially, the Stinger teams positioned in depth along the expected escape routes or in the flanks of the valley. The sequence of engagement was choreographed. As a pair of Su-25s or a MiG-23 flight approached for a strike, the EW operator would power up the ALQ-167. The targeted aircraft's radar would fail, as would any attempt to use radar-guided munitions. Confused and suddenly deprived of his primary attack sensors, the pilot would be forced to abort his run. He would likely initiate a defensive turn, popping flares in anticipation of a stinger he couldn't yet see. This turn would bleed off his airspeed and altitude, and more importantly, it would make his aircraft's heat signature more predictable. This was the moment the Stinger teams waited for. A turning, climbing, or descending aircraft is more vulnerable than one in a fast, straight attack run. The sudden confusion caused by the jamming created a perfect window of opportunity. The first missile would launch. Whether it hit or missed, the effect was catastrophic for Soviet cohesion. The flight would break formation, each pilot diving for the deck in a panic, their attention wholly consumed by surviving the infrared threat. In the chaos, discipline broke down. The carefully rehearsed Soviet tactics for mitigating Manpad's threats, maintaining high speed, using the sun, coordinating flare discharges, disintegrated. They became individual targets, not a unit. The psychological warfare component was equally potent. The Mujahideen learned that even the threat of jamming could alter Soviet behavior. In some documented cases, after experiencing radar failures in a specific valley, Soviet pilots would begin avoiding that airspace altogether, ceding tactical control without a fight. Entire regions became informally no-fly zones due to the suspected presence of the invisible weapon. The pod's value was not just in the missions it disrupted, but in the vast tactical freedom its reputation created. It forced the VVS to constantly second-guess their electronic environment, slowing decision-making and adding an insidious layer of stress to every sortie. Navy Training Warehouse to a mountainside in Paktia province is a definitive case study in Cold War covert technology transfer. This was not a simple arms shipment. It was a cycle of intelligence, engineering, and deception. The circuit began with collection. Signals intelligence, SIGINT, was paramount. Listening posts in Turkey, Iran, before the revolution, and from reconnaissance flights along the Soviet border had compiled extensive libraries of Soviet radar emissions. Every Soviet aircraft type had a unique electronic fingerprint, its pulse frequency, scan pattern, and power. When the Soviet Union deployed its forces to Afghanistan, these signatures moved from theoretical databases to active, real-time collections. RC-135 rivet-joint aircraft flying perilous orbits just outside Afghan airspace vacuumed up electronic emissions from every Soviet flight. This data was refined and analyzed by the CIA's Office of Scientific and Weapon Research and the NSA. The next step was engineering the solution. The CIA needed a jammer that was effective, portable, and deniable. The AN/ALQ-167 was ideal. As a training pod, it was not on the strictest munitions control lists. It was also modular. Its internal blister modules, which generated the jamming signals, could be swapped out. CIA technical officers working with contractors designed new modules specifically tuned to the I-band and J-band frequencies of the Su-25 and MiG-23 radars. They perfected the deceptive jamming techniques that would cause maximum confusion. S markings were removed, they were repainted, sometimes crudely, and packaged for shipment. The logistical pipeline ran through Pakistan. C-141 Starlifter transports would deliver pallets of equipment to Islamabad. Under ISI supervision, the cargo was transferred to trucks for the journey to Ojri camp in Rawalpindi, the central clearinghouse for Mujahideen supplies. Here, CIA and ISI specialists conducted final training. Mujahideen commanders and their chosen technical operators, often men with some background in radios or mechanics, were given crash courses. They learned to identify the pod's controls, how to aim its directional antenna, and the crucial timing for its activation. The training was visual and practical. See this aircraft, turn this dial, press this button. Finally, there was the art of deception. To protect the secret and magnify its psychological impact, a deliberate fog of misinformation was created. If a pod was captured, its origins were to be murky. The CIA encouraged rumors that the jamming effect was the work of captured Soviet equipment, or even that it was divine intervention. Government, but it also served a tactical purpose. It delayed the Soviet Union's accurate assessment of the threat. As long as the Kremlin suspected a technical fault or an accidental emissions problem, they would not invest in a rapid, theatre-wide countermeasure. The confusion was a weapon in itself. This four-part cycle, collect, engineer, deliver, and obscure, created a silent revolution on the battlefield. It demonstrated that in a proxy war, the most decisive weapon could be a stream of data, translated into a specific electronic frequency, and unleashed with precise tactical timing. The Soviet pilot, battling the visible streak of a Stinger, was merely fighting the last layer of a deeply integrated, intellectually crafted kill chain. The turning point was not a single thunderous battle, but a creeping tide of unexplained failures. It manifested in a series of isolated, bewildering incidents across the Afghan theatre in late 1986 and early 1987, each one a data point in a pattern the Soviet High Command was slow to recognize. November 1986. A flight of two MiG-23 MLDs from the 217th Fighter Aviation Regiment was tasked with hitting a Mujahideen convoy reported in the rugged Logar Valley south of Kabul. The lead pilot, Major Alexander Gordienko, relied on his Sapphire radar to pick out the moving vehicles from the ground clutter. As he descended for his attack run, the crisp returns on his scope, the distinct blips of trucks, dissolved into a frenetic, shimmering haze. He switched modes from ground-moving target to mapping, the same chaos. Assuming a critical malfunction, he aborted, signaling his wingman to do the same. They returned to base, where technicians spent days examining the aircraft. No fault was found. The the radar tested perfectly. The incident was logged as anomalous atmospheric interference, a phenomenon sometimes noted in mountainous regions, though never before with such totality. January 1987. A pair of Su-25s providing top cover for a Soviet armoured column was called in to suppress firing points in the hills overlooking the road. The lead Frogfoot pilot, Captain Viktor Pavlov, initiated a shallow dive, his Shkval system slewing to the coordinates provided by the ground commander. To verify his position in the complex terrain, he toggled his Shtik ground mapping radar. The display, which should have shown the distinct line of the highway and the rise of the hills, was a flat, featureless green glow. He could see the valley visually, but his electronic confirmation was gone. 2 identical simultaneous failures. Pavlov, feeling exposed, ordered a climb and jettisoned his bombs harmlessly in a cleared area. Back at Bagram, the regimental commander heard 2 nearly identical reports from experienced pilots. The coincidence was troubling. The technical officers began whispering about a possible batch defect in recently supplied radar components. March 1987. This incident involved the heaviest dedicated close air support aircraft in theatre, the Su-25. A full flight of 4 Frogfoots was dispatched to strike a major base belonging to Ahmad Shah Massoud's forces. The operation was planned meticulously, with timed runs from different axes. The first element of 2 aircraft made their pass successfully, deploying bombs and pulling up. The second element, rolling in moments later, was met with electronic silence. Both pilots reported complete loss of ground mapping and ranging data. Their attacks were scattered and ineffective. More critically, as they egressed, a Stinger missile was fired. It missed, but the ensuing evasive manoeuvres scattered the flight. The post-mission debrief was tense. The pilots of the second element were adamant. Their systems didn't fail. They were erased. They spoke of a heavy electronic feeling in the air. The pilots from the first element reported no issues. This was the critical clue. The effect was localized and timed. It was not a widespread atmospheric event. It was a switch being thrown. These scattered reports began coalescing into a disturbing pattern at the headquarters of the 40th Army's Air Force and the VVS main staff in Moscow. The initial dismissals, pilot error, technical gremlins, mountain weather, became less tenable. Too many seasoned combat pilots from different regiments flying different aircraft types were reporting the same phenomenon: a sudden, total and temporary loss of primary attack radars in specific geographic areas. The correlation with increased Stinger attacks was impossible to ignore. It suggested coordination. The GRU, Soviet military intelligence, was tasked with finding the source. Their field agents within the Mujahideen and their intercepts of Mujahideen communications began picking up intriguing fragments. More concretely, signals intelligence units deployed on the Afghan border started detecting unusual low-power transmissions in the I and J bands. These were not communication signals, they were pulsed, rhythmic emissions that matched nothing in their databases of known Afghan or Pakistani military equipment. They were, however, hauntingly familiar in their frequency structure. They sounded like distorted echoes of the VVS's own radar pulses. The turning point from mystery to revelation was likely precipitated by a piece of physical evidence. While the exact incident remains classified, the sequence is consistent with known Soviet procedures. In the aftermath of a Mujahideen ambush where a Soviet aircraft was downed by a Stinger, a more frequent occurrence, a Spetsnaz recovery team or a particularly diligent ground unit would be sent to the crash site. Their orders were to secure the pilot's body, if possible, and destroy any sensitive avionics, particularly the IFF transponders and crypto equipment. In the wreckage of a MiG-23 or Su-25, downed in areas where radar jamming had been reported, technicians would have found the aircraft's own systems fused and crushed. But the clue was not in their own wreckage. It would have been found a kilometre away, on a rocky outcrop that had a clear view of the crash site. There, perhaps hastily abandoned in the retreat after the successful strike, would be the remnants of a position. Battery packs, wiring, and if they were extraordinarily lucky, the mangled but recognizable carcass of a cylindrical pod. It would not look like a conventional weapon. It would have non-Soviet connectors, circuit boards with Latin alphabet designations, and a ruggedized casing that spoke of military, but not Soviet, manufacturing. That object, transported under guard to Moscow, would have been the Rosetta Stone. Delivered to the secretive institutes of the Soviet electronics industry, the Voyeno-Promyshlennaya Komissia, Military Industrial Commission, it would have been autopsied by furious, fascinated scientists. The mangled pod, or its critical components, arrived at the Scientific Research Institute of Radio Instrumentation, NIIRP, in Moscow, a top-tier facility responsible for the very radars it had just defeated. The autopsy was conducted in a state of profound professional alarm. The Soviet engineers immediately recognized the architecture. This was not a crude, broad-spectrum noise jammer of the type they themselves produced for frontal aviation. The circuitry was dense, miniature, and sophisticated. The modular blister tuning units were a giveaway. This was a system designed for flexibility. Most damningly, the frequency-agile oscillators and the digital memory modules, which could store complex modulation patterns, were analyzed. They found the ghost in the machine. The jammer's core programming was specifically optimized to listen for and then replicate with subtle corruption the exact pulse repetition frequencies of the Sapphire 23 and Shtick radars. This was not a weapon of opportunity. It was a tailored suit cut from the cloth of Soviet emissions. The implications of this forensic report, circulated in a classified spravka to the Central Committee of the CPSU and the High Command of the VVS, were tectonic. The United States was not merely supplying defensive weapons to level the playing field. It was conducting a coordinated electronic warfare, EW offensive, through proxy forces. This crossed a threshold. The Stinger was a grave tactical threat, but it existed within an understood paradigm of arms supplies, the portable anti-aircraft missile. The ALQ-167 was different. It was an instrument of command and control denial, a direct attack on the Soviet military's ability to observe, orient, decide, and act, the core of the OODA loop. It signaled that the CIA was willing to transfer technology that blurred the line between guerrilla tool and strategic-level warfare system. The realization sparked a crisis that was both technical and doctrinal. Technically, the VVS had no immediate countermeasure deployed in Afghanistan. Their tactical aircraft lacked the sophisticated ECM, electronic countermeasures suites, of their strategic bombers or dedicated EW planes like the Mi-8 PPA helicopter. A Su-25's self-protection suite was the SPO-15 RDUR and flare dispensers, useless against this. They needed a hard kill solution, a way to locate and destroy the jammers. This led to the frantic, makeshift deployment of Yastreb radio direction finding equipment on Mi-8 helicopters. Crews would attempt to triangulate the jammer's position when it activated, so it could be marked for artillery strike or a Spetsnaz raid. But the process was slow, and the jammer could be switched off and moved. The deeper shock was doctrinal. Soviet military theory placed electronic warfare as a critical but opening phase of a major conventional war against NATO. It was the domain of specialized units using massive vehicle-mounted systems to blind enemy air defenses across a front. The concept of a single man-portable pod, operated by an illiterate guerrilla in a counterinsurgency, achieving a similar tactical effect, was a profound intelligence and conceptual failure. S was waging a war of technological experimentation, using Afghanistan as a live-fire laboratory. This realization forced a brutal and costly adaptation at the tactical level. New draconian flight procedures were issued. 1. Radar silence. Pilots were ordered to keep their radars switched off until the final moments of an attack run, relying solely on visual and inertial navigation to approach the target. This increased navigational errors and made finding mobile targets nearly impossible. 2. Wild weasel tactics. Pairs of aircraft would fly missions where one, acting as bait, would turn its radar on to deliberately attract the jammer. The second aircraft, flying at a higher altitude with its radar off, would attempt to visually spot the launch site or direct artillery. This put the bait pilot at extreme risk. 3. Brute force attacks. The preferred solution became the use of unguided rockets and bombs in massed area saturation strikes. Coordinates would be calculated from maps before takeoff. Aircraft would fly to the point and release their entire payload in a single pass, hoping to blanket the area where the jammer might be. This wasted ordnance, increased collateral damage, and further eroded the already tenuous hearts and minds effort. 4. Escalation in altitude. The already high attack altitudes forced by the Stinger were pushed even higher to stay outside the optimal line of sight range of the ground-based jammer, further degrading accuracy to a symbolic level. The climax of this phase was not a victory, but a grim acceptance. The bafflement had crystallized into a hardened, pessimistic awareness. They knew an invisible system was at work, one that partnered the physical threat of the missile with the sensory threat of blindness. The sky was no longer a sanctuary, it was a domain contested in a spectrum they could not see. A mission was now a dual gamble, against the visible streak of the Stinger and against the silent nullification of their own technology. This electronic siege, layered upon the bloody stalemate on the ground and the constant drip of casualties from Stingers, became a powerful argument within the Soviet Politburo. The war was not just militarily unwinnable, it was becoming a technologically losing proposition, a drain of prestige and resources with no end in sight. The invisible waves of the ALQ-167 pod did not down aircraft like the Stinger, but they did something perhaps more damaging. They made the Soviet war machine look obtuse, slow, and ultimately defeatable in the face of Western innovation. The immediate consequence of the electronic warfare revelation was a tangible degradation of Soviet combat power at the tactical level. The integrated Stinger and Jammer threat system forced a retreat into less effective, more costly methods of operation. Close air support, the bedrock of Soviet counterinsurgency tactics, was neutered. Sortie counts might remain high, but their lethality plummeted. Pilots, now navigating and attacking using essentially World War II-era visual methods from high altitude, could no longer provide the precise, responsive fire that ground troops desperately needed during ambushes. The Soviet 40th Army found itself increasingly isolated, its mobility choked without reliable air cover, forced to move in massive, defensible convoys that were themselves lucrative targets for ground ambush. The financial and logistical costs skyrocketed. The knee-jerk response of saturation bombing wasted thousands of tons of ordnance for minimal effect. The desperate attempts to develop and field countermeasures drained resources. The Yastreb direction-finding helicopters and their crews were a new drain on an already overstretched aviation branch. Every adaptation was a tax, but the deepest cost was in morale and institutional confidence. A previously unassailable pillar of Soviet military might, its tactical air arm, had been outthought and out-teched by a supposedly primitive enemy. The reports flowing back to the VVS main staff were not of glorious victories, but of technical puzzles and forced retreats. The phrase radar interference became a sterile, bureaucratic euphemism for a profound tactical defeat. This technological blowback accelerated a strategic reassessment already underway in Moscow. The Politburo, under Mikhail Gorbachev, had been searching for a path out of the bleeding wound of Afghanistan since 1985. The military arguments for staying had long rested on the belief that superior technology and firepower would eventually grind down the resistance. The events of 1986-87 dismantled that belief. The Stinger had shown that the Mujahideen could reach out and kill high-value aircraft. The jamming pods showed they could, with outside help, contest the very information domain. The war was not stabilizing. It was escalating in ways that played exclusively to the strengths of the insurgents and their sponsors. Gorbachev's famous speech at the 27th Party Congress in February 1986, calling Afghanistan a bleeding wound, set the political stage. The military shocks that followed provided the concrete justification for the policy of national reconciliation announced in 1987, and the ultimate decision for a full withdrawal. While not the sole cause, the electronic warfare setback was a powerful data point for the reformers and military realists, arguing that prolonging the conflict would only lead to more humiliations and the potential loss of even more advanced secrets. Why risk a next-generation MiG-29's radar being compromised in the same way? The aftermath for the Mujahideen and their handlers was one of unqualified success. It proved that a small, cheap, technologically sophisticated component could multiply the effectiveness of a larger, simpler weapon system, the Stinger, and alter the behavior of a superpower's military. The pods were force multipliers of the highest order. They created sanctuaries, preserved key leadership and supply bases from effective air attack, and conserved valuable Stinger missiles for the most promising shots. For the CIA, it was a case study in how to wage a war by proxy with minimal risk and maximum deniability, a lesson meticulously documented and filed away for future conflicts. The battlefield itself bore the scars of this invisible struggle. Soviet aircraft flying higher and faster dropped their bombs with less discrimination. Civilian casualties from airstrikes likely increased even as military effectiveness decreased, a tragic paradox of imprecise, fear-driven tactics. The electronic war had no visible craters, but its effects were written in the abandoned villages under wider bombing patterns and in the grim faces of Soviet pilots who now viewed their own cockpit instruments with suspicion. The shockwave reached the Soviet design bureaus and military electronics institutes with the force of a revolution. The war in Afghanistan had exposed a critical vulnerability in what was supposed to be a second echelon theatre. It sparked a frantic, though often bureaucratically sluggish, push to develop and field ECM pods for tactical aircraft. This led to accelerated work on pods like the SPS-141MVG Sorbtseer for helicopters and later more advanced systems for fixed-wing aircraft. The experience directly influenced the design requirements for the next generation of Soviet combat aircraft, emphasizing built-in, sophisticated electronic warfare suites as a standard feature, not an add-on. The notion that any future conflict would include a pervasive EW threat from the first day was now burned into the Soviet military consciousness. But this awakening came at the end of an era. As Soviet engineers raced to close a technological gap revealed in the Afghan mountains, the political decision to abandon those mountains had already been made. The Soviet withdrawal in 1989 did not end the story of the electronic pods. Their legacy rippled outward, shaping strategies, technologies, and doctrines on a global scale. The first and most direct consequence was an intelligence bonanza for the West. The successful deployment of the ALQ-167 was not merely a tactical win, it was a comprehensive test under live fire conditions. CIA and Pentagon analysts gained invaluable data on how Soviet radar systems and their operators behaved under sophisticated jamming pressure. They learned about system reset times, pilot reactions, and the limitations of Soviet airborne EW countermeasures. This real-world performance data, impossible to fully replicate in training exercises, was fed directly into the development of next-generation American jamming systems, such as the AN/ALQ-165 ASPJ, Airborne Self-Protection Jammer, and later the AN/ALQ-214 on the FA-18. The Afghan mountains had served as the ultimate proving ground. For the Soviet, and later Russian, military-industrial complex, the humiliation was a permanent scar and a powerful motivator. The experience forged a near-obsessive focus on electronic warfare that defines Russian military doctrine to this day. The lessons of Afghanistan directly catalyzed the development of a suite of ground-based EW systems designed to create localized bubbles of electronic denial, a direct institutionalization of the tactic used against them. Systems like the Krasuka and Murmansk BN, which can jam airborne radars and communications over vast distances, are the spiritual and technical descendants of the countermeasures they lacked in the Hindu Kush. The Russian emphasis on radio-electronic combat, REC, treating EW as a combat arm co-equal with artillery or infantry, was hardened in the crucible of this experience. They learned that the electromagnetic spectrum is a battle space to be dominated, and they have built their modern military accordingly. The blowback also took an unexpected and deadly turn in the post-Soviet chaos. When the Najibullah government fell in 1992, the vast arsenals of the defeated Democratic Republic of Afghanistan, including an unknown number of the CIA-supplied ALQ-167 pods and their technical documentation, were scattered. They became part of the lethal bounty available on the global black market. While a Stinger missile is a direct-use weapon, a jamming pod is a tool of immense value to signals intelligence agencies and non-state actors with technical ambitions. It is highly likely that Iranian Revolutionary Guard Corps Quds Force technicians acquired examples, accelerating their own indigenous EW programs. The knowledge embedded in that technology, how to blind specific Western radar frequencies, began to diffuse, a ghost of the Cold War haunting future conflicts. Perhaps the most profound legacy was doctrinal. The success of the Stinger-Jammer combination demonstrated the devastating effectiveness of cross-domain or multi-spectrum denial. It wasn't just a missile bissau, it was a system that paired a kinetic kill mechanism, Stinger, with an information denial mechanism, Jammer. This blueprint, using one tool to force an enemy into a predictable behavior that makes them vulnerable to another, became a cornerstone of modern asymmetric and hybrid warfare. One can see its echo in contemporary conflicts. Drones used to spot for artillery, cyber attacks crippling air defenses just before a missile strike, or social media propaganda used to mask troop movements. The Afghan Mujahideen, guided by the CIA, were early pioneers of this integrated battle space. For the United States military, the experience was a double-edged lesson. It validated the power of covert technology transfer as a force multiplier. However, it also created a dangerous confidence in technological silver bullets and the controllability of proxy warfare. The belief that advanced technology could be surgically implanted into a conflict, achieve decisive effects, and then be withdrawn without broader consequences proved to be an illusion. The very militants trained and equipped by the CIA and the ideologies fueled by the anti-Soviet jihad would later turn their acquired skills and surviving weapons against their former benefactors. The war demonstrated that while technology could dictate the tempo of battle, it could not control the political and ideological aftermath. Finally, the episode marked a symbolic shift in the narrative of the Cold War. For decades, the image of Soviet technological prowess, epitomized by Sputnik and vast armored columns, was a source of anxiety in the West. In the skies over Afghanistan, that narrative was inverted. It was Soviet pilots who were baffled, confused, and rendered vulnerable by Western electronics. It was the USSR that was shown to be tactically rigid and slow to adapt. This psychological victory, though hidden in classified reports at the time, contributed to a growing sense in both East and West that the Soviet system was not just politically stagnant, but technologically backward in the emerging fields that would define the next century. Digital processing, microelectronics, and network-centric warfare. The silent war of jamming pods was a quiet prelude to the louder collapse of an empire. The story of the baffled Soviet pilot and the silent jamming pod is more than a tale of technological surprise. It is a parable about the changing face of war itself. For millennia, the battlefield was defined by what could be seen and heard: the line of pikes, the thunder of cavalry, the flash of artillery. The 20th century added a new layer: the invisible realm of the electromagnetic spectrum. In Afghanistan, that invisible realm became decisive. The conflict demonstrated that supremacy in this hidden dimension is not a function of brute force, but of subtlety and intelligence. It is a war of signatures and silences. The Soviet Union possessed overwhelming physical power, jets, bombs, and helicopters in abundance. Yet a precisely tuned signal, a replica of its own electronic heartbeat reflected back as noise, could nullify that power. The most formidable armour was rendered irrelevant against an attack that bypassed steel entirely, targeting instead the flow of information within the cockpit and the confidence within the mind of the man flying it. This shift announced the arrival of the cognitive domain as the ultimate high ground. The goal was no longer solely to destroy the aircraft, but to degrade the pilot's ability to make decisions, to shatter his trust in his machine, and to force his vast military organisation into wasteful, reactive postures. The jamming pod was a psychological weapon as much as an electronic one. Its success was measured not in wreckage on the ground, but in missions aborted, in sorties flown uselessly high, in the gnawing fear that the tools of mastery could become instruments of blindness. The legacy of this silent struggle is etched into every modern conflict. The lessons written in the ionosphere over the Panjshir Valley are now doctrine. Today's battlefields are saturated with sensors, drones, GPS-guided munitions, and networked communications, all of them vulnerable to the same principles of denial and deception. The contest is no longer just for hilltops and cities, but for bandwidth, for satellite links, for radar frequencies. The soldier on the ground, the pilot in the air, and the commander in the bunker are all equally dependent on an invisible matrix of data that can be severed, corrupted, or spoofed. In the end, the Soviet-Afghan War revealed a fundamental asymmetry of the late Cold War. While the USSR excelled at building monumental, centralized systems of steel and explosive force, its adversary was learning to wield precision, information, and adaptability. The pilot, baffled by his blank radar screen, was a metaphor for a superpower confronting a new kind of challenge, one where its vast, rigid strength could be offset by a small, clever, and invisible hand. The mountains of Afghanistan have long been called the graveyard of empires. For the Soviet Union, they also became a classroom, though the lessons came too late. The most important lesson was that in the modern age, the pathways to defeat are often silent, unseen, and transmitted on frequencies far beyond the range of human hearing. The war of the future had arrived, not with a roar, but with a whisper of targeted static, and in that whisper, one empire began to hear the echo of its own obsolescence.